Suppose a positive test charge Q is at an infinite distance from an electrically charged rod. Since there is zero interaction between the test charge Q and the charged rod, the electric potential energy is 0, U, equal to 0. The test charge Q is brought to a point A in the electric field of the charged rod. Now the work done, W, by the electric force acting on the test charge Q is given by the relation U, equal to, minus W. The electric potential, V, is given by V, equal to, minus W by Q, equal to, U by Q. The figure shows an electric charge of plus Q, at point A in the electric field, of an electrically charged rod, has electric potential energy, equal to, U, equal to, minus W, and electric potential, equal to, V, equal to, U by Q. If the charge is at an infinite distance from the charged rod, electric potential energy, equal to, U, equal to, 0. Electric potential, V, is defined as the amount of potential energy per unit charge when a positive test charge is brought in from infinity. An electrically charged object sets up electric potential, V, throughout its electric field, regardless of whether a charge is there or not. The potential energy, U, of a charge, Q, placed at a point having a potential, V, in the electric field of a charged object is given by potential energy, U, equal to charge, Q, multiplied by potential, V. The figure shows the electric field of an electric charge of plus Q, and the electric potential in the electric field. Since V, equal to W by Q, the SI unit for potential is joule, J, per coulomb, C, J by C or, volt, V. 1 volt is equal to 1 joule per coulomb, 1 V, equal to 1 J by C. Volt, V, is a derived unit for electric potential. Volt is named in honor of Alessandro Volta, an Italian physicist who invented the voltaic cell, an electrochemical battery. Since both electric potential energy and charge do not have a direction associated with them, they are scalars. Since electric potential, V, equal to electric potential energy, U, by charge, Q, electric potential, V, is a scalar. Electric potential, V, can be positive or negative since electric potential energy and charge can be positive or negative. The table shows the sign of V, equal to, U by Q, depending on the sign of U and Q. If U and Q both are positive, V is positive. If U is positive and Q is negative, V is negative. If U is negative and Q is positive, V is negative. If U and Q both are negative, V is positive. Moving a charged particle with charge, Q, from point A at potential VA to B at potential VB in an electric field of a charged object, the electric potential difference delta V, is given by delta V, equal to, VA minus VB, hence, the potential energy difference, delta U, is given by delta U, equal to, Q multiplied by, VA minus VB, equal to, Q delta V. Delta U can be positive, or negative, depending on the sign of charge, Q, and potential difference, delta V, or even 0 if delta V, equal to, 0, that is VA, equal to, VB. The change in electric potential energy, delta U, is independent of the path through which the charge, Q, moves from point A to point B in the electric field. The figure shows, a charge of plus Q, moves from point A to B in an electric field. The electric potential changes from VA to VB. Voltage is the potential difference, delta V, between 2 points. Voltage is defined as the potential energy or work per unit charge when a positive test charge is moved from an initial point to a final point in an electric field of a charged object. Since voltage, delta V, is the difference in electric potential at 2 points and electric potential is a scalar, voltage is a scalar. The SI unit of voltage, delta V, is the derived unit volt, V. A voltmeter can be used to measure the voltage between 2 points. Conventional current always flows from a higher potential to a lower potential. The figure shows a battery which provides a voltage or potential difference, a voltmeter to measure the voltage, and an electric circuit with battery, wire, and load. A current I1 flows in the circuit. The conventional direction of this current is from the higher potential, that is, the positive terminal or anode of the battery, to the lower potential, that is, the negative terminal or cathode of the battery.